In the following exercises, calculate the integral by interchanging the order of integration. So we're going to do number 14 here. So it says by interchanging the order of integration. Now this is an important idea, maybe not necessarily with these over the rectangular region, but when it comes down to actually calculating some of these integrals by hand. So that means if I'm going to switch my integration, I'm going to have the integral then, and I'm going to leave those bounds alone for a minute. But nothing here changes. That's going to be x plus 2e to the y minus 3. Now this is where it changes here. So this is now not going to be dx anymore, but dy, and then dx is going to come last. Okay, so then now that tells me for my bounds, now keep this in mind, my dx bounds, my change in x, is going to be 0 to 1. So that means since I swapped them, this now is my 0 and 1. That's my dx, and that's what I do last. So then my dy bounds is going to be the 0 to 2, and that's what we see last on this one, which means the bounds are the last out there, because remember, we work from the inside out. So this is going to be our design here for this problem now. Okay, so what we're going to do first is, again, we work from the inside out. So that tells me I'm going to integrate this with respect to y. So now anything, I should say any term that doesn't have a y in it is considered a constant. So when I look at this x is a constant because I have a plus here. And this negative 3 is a constant. And again, I can split across addition and subtraction. That's why that's so evident here. So now, when I write this out, this is going to equal. I still have the 0 to 1 because I'm not touching that one yet. But when I integrate this with respect to y here, so the x plus 2e to the y minus 3, this is going to be xy. And we get plus, now the derivative of e to the y is e to the y, and that has a variable y in it, so I'm going to treat it as so. So that's going to be 2e to the y, and then minus 3y, and that's going to go from 0 to 2. And then I still have my dx that I'm going to do next. Okay, so now this equals, still the integral from 0 to 1. Now we're going to actually start plugging in for our y here. So now 2 goes in first because it's upper bound minus lower bound. So we can see that it's going to go to all three of those places. So I'm going to get 2x plus 2e to the second minus 3 times 2. And then I'm going to subtract the lower bound. I'm going to use a bracket here just so I don't miss anything. And when I plug in here, this 0 in this first piece here is going to be 0 times x. So that's going to be 0 plus, now there's a y there, so that's going to be 2e to the 0. And then I have a minus here. When I plug in the 0 for y there, that's going to be 3 times 0. So that's going to be 0. And I still have my dx. So now this is going to be the integral from 0 to 1. And I'm going to have 2x plus 2e squared minus 6. And now I'm here. Okay, now that's 0. And this subtracted here is going to be minus 2, and I say 2 because e to the 0 is 1. So 2 times 1 is 2, and then dx. And now let's clean this up a little more. So this is going to be an integral from 0 to 1, 2x plus 2e squared minus 8 dx. So now this integral is just power rules. And keep in mind here, 2e to the 2 is just a number altogether. So when I integrate this 2x first, I'm going to get x squared plus 2e squared times x minus 8x, and that's going to be from 0 to 1. So now, upper bound minus lower bound, when I plug in a 1, I'm going to get a 1 squared plus a 2e squared times 1 minus 8 times 1, that's the upper bound, minus the lower bound, I'm going to end up with 0 plus 0 minus 0. And hopefully you're okay with that. If not, run through it, make sense of it. So then, this is then going to be 1 plus 2e squared minus 8, which equals negative 7 plus 2e squared as our final answer for this problem. All right, and we talked about changing the bounds. So just keep that in mind, that changing of bounds is something that's going to come in handy for us, or I should say interchanging the order of integration. That really comes in handy for us later on with some of the integrals, because some of them we can't do unless we interchange the order of integration. But that's our answer for this one.